Okay, so now that we've defined work as FD cosine theta, let's apply the definition to solving some simple problems. Okay, so the first one is the following situation where we have a 10 kg block and we're exerting a force of 100 newtons to the right, and we're asking what is the work done by the force F, the work done by gravity, the work done by the contact force, and then the work done by the force of friction. So let's figure out all the work done, and along the way, we'll also look at some of the subtleties that one must keep in mind. Okay. Again, remember WF is equal to FD cosine theta, and the angle theta is between the particular force that we are interested in and the displacement. Now here, let us say that the object travels a distance of 10 meters to the right. Alright, so let's proceed. Let us first find the work done by the force, the 100 Newton force. Now, in order to do this, what I'm going to do is I'm going to draw the 100 Newton force, and then I'm going to represent the displacement in red, and D is equal to 10 meters. Now, my definition is WF equals FD cosine theta, so W100 is equal to F, which is 100, D, which is 10, and then theta. Now, when the force is pointing in the same direction as the displacement, theta is simply equal to 0 degrees. And when we compute this, we end up getting 1000 joules. So that's the unit of work. Okay, so we have one answer here. Let's proceed. Let's figure out the work done by the force of gravity. Now if you look at the problem, we have a 10 kg block. Gravity is 10 times 9.8, which is mg, and the object's displacement is to the right. And if you notice here, the angle between the two is 90 degrees. So we know that the work done by gravity, which will be equal to 98, multiplied by 10, multiplied by cosine of 90, and this is nothing but 0 joules as expected. Let's repeat this for the work done by the force of contact. Fn points up, and the object's displacement is to the right, 10 meters. And from our free body diagram, we know that in this case, since there are no forces other than contact and gravity in the vertical direction, the contact force is simply equal to 98 newtons. So now this gives me the force, the work done by contact is simply equal to 98 multiplied by 10 and multiplied by cosine of 90, which once again happens to be 0. So once again here, the angle theta is what determines whether the work is 0. And now the last one is the work done by friction, for which we first need to find the force of friction. So my force of friction is simply mu times Fn, and this is equal to zero point 0.5 multiplied by 98, which happens to be 49 newtons. Okay, so we now know the force of friction. Let's draw the picture. The object's displacement is 10 meters to the right. The force of friction is to the left, and we see from this picture that the angle between the two is 180 degrees. So now what I have is I have 49 multiplied by 10 multiplied by cosine of 180, and this gives me negative 490 joules. So now we have the work done by all the forces, and we could find the net work done as the sum of all the works. In this case, it happens to be 4 of these. So I get 1000 plus 0 plus 0 minus 490, which happens to be 510 joules. So this is applying the definition and to a simple problem. And some of the important things is drawing the forces and the displacement for each of the, when you're calculating the work done by each particular force. So just do it carefully, and then you'll realize that you are making mistakes. All right, we'll continue.